Sorry for the shakes. Oh, I'm terrible at this. I can't even steady my hand. There. Anywho, so in looking, going over, trying to redevelop and redevelop my speculation as to what direction I want to take in replicating a ghost of a similarity to what Clarence and Barbosa and Leal have done, without attempting to replicate it in full or accurately in any sense of the way whatsoever. Just, being a kind of creative artist and seeing where each step takes me, feeling my way through, using my body as my oscilloscope, and directly connecting my body to the karma, to the experience, the direct experience of the device, at least in its initial stages of development, before I actually power it up. So what I've done is I've come up with this kind of semblance of an idea. If I can show what it amounts to. Basically, it's a chain link, a daisy chain link, similar to Eric Dollard's analog computer in LMD mode, in which I have the two toruses combined, the primary wound around the center post, let's focus in here, and two diodes above and below pointing inwards, one of them grounded to a vertical plate, and the other simply connected to a top line that ends in a capacitor. And this, it might be a little wrong in here, but at least try to ignore it, because I think it should be different, as you'll well, actually, yeah, I didn't draw the other version because I wasn't sure I wanted to go in that direction. But just let's go with it for the moment. So you got a neon bulb, a center plate, which doesn't make any sense, because that would mean both sides would be the same sign, and this thing would not operate in an AC mode, which is what analog computer in LMD mode does, as so far as I can recall. Anywho, then you got a load here, loose coupling here to another grounding plate, which of course doesn't make any sense, right? And a shunt over here, and then the next, part of the chain. So in keeping with that, what I did was I decided, okay, what if, let's see if I can steady this somewhat. Okay, back up a little. So what I thought was, how can I make a DC version of the LMD analog computer? And that is to freeze it in 1/2 phase. So let me focus in just a little. So these dark lines in the center represent bar magnets. And every other one, they're flipped. So north above south, south above north, and likewise, so on and so forth. And now that's inside the primary winding, which goes around it, which creates an orientation and a flow that's fixed to this magnetic piece. Now, if I alternate it over here, that means I've got the correct oppositional polarity across the two plates of this capacitor here, and they all share earth-ground, just as they share a wire connection above. And then in the last example, let's see, in the last example I try to point out, well, how would I do a load? And so what I'm imagining, I might as well move in, is that the chassis surrounding the load is the ground of the captor loop. And so the captor loop comes up, and since, let's see if I got this right, the load is between the short and the top load, represented by the neon bulb. So it comes around here, encases itself by the surrounding chassis, which is now common ground, and then it goes to the neon bulb, and then it goes to its little antenna, and of course the neon bulb doesn't need a resistor because the load is the resistor, or you put them together. You assume them to be together because they're in line, directly in series adjacent to each other. So that's how I would envision how a load can be taken off of each electric keeper, the secondary in between, in the middle of each daisy chain here, each module of the analog computer in LMD mode. So this was one case, and then I imagine, in this case, 4, an even number, of flipped bar magnets can be encircled, can come back and tie into itself. So these double lines are the capacitors, and these rectangles are the top view coming down, looking down of each of these double toroid, square-shaped E-form toroids with the top bar, the E-form transformer core with the top bar across them. And so among here, not drawn, would be the loops that a load could be taken off to some limited degree, obviously, not too much. See, because what I was thinking was, this is all very well and good, but there's nothing powering it. This at least had an AC inverter powering the thing. And so I'm thinking, okay, I need a power source, and so that'll be the bar magnet inside the primary winding, which this is a slight enlargement of. Then I thought, okay, what if I get away from these multiple daisy chains and go back to just one? Go back to the original idea of just a single pair of toroids with their primary and secondary windings. How would it look? What would I do? Taking what I've learned or what I've developed ideologically, how much can I transfer over to the new design? So this is what I'm left with. Again, still, like before, no source of power at this point, just a circuit layout. So maybe I should back up a little bit. Except it's hard to hold steady. So here I got my two toroids now separated, as they were before. And I've got the electric keeper, the secondary, and as Clarence has said, the top links to top. You lay these down on the table, and what's facing up? That's the top. So the top here connects with the top here. The bottom there connects with the bottom over here. And it's not twisted if you look at it sideways, going this way, along the tabletop. It's only from above, maybe it appears like it's twisted, but that's not the point. The point is relativistic to the table, facing up, away from the table. And of course these are both counterclockwise wound, while the primary is clockwise in each case. Now I put two diodes at either end pointing in like before, and then I have to put the capacitor over here. See, I thought I was going to have it up here. You can see a lot of tape because I made mistakes and I had to make corrections. Actually, it goes here because it'll be flipping this way. It'll be positive on one side, negative on the other. It may not flip, but it has to be oriented. Positive on one side, negative on the other, and that's what the capacitor is for, is to set up polarity. It's not intended to store charge per se. I mean, that's what it'll end up doing, but its purpose here is to set up polarization between top and bottom, at least to signify that there's supposed to be polarization, so that if there's any charge going through here, it'll tend to collect in a polarized fashion. I mean, that's the whole point, is, what's the word I'm looking for? Dispersion of charge? The opposite of unification, because when you unify, you create similarity, but when you want to diversify into a pair of opposites, they have to take on characteristics that are opposed to one another instead of being androgynous clones of each other. So they're still clones of each other, but the only difference is they're not androgynous. So one takes on male characteristics, or yang, or positive, and the other takes on female characteristics, or negative, yin. And only in those two respects of sign value do they differ. In all the other respects, they're the same. In other words, the magnitude of charge on either side of the dielectric of this capacitor has to be equivalent, or else you're going to get oscillation, a tank circuit, which could happen. You got a coil here, and you got a capacitor there, only I don't know about these diodes, what that's going to do. I'm doing this on the basis of experience, of what has worked on my sleep circuit. I sleep on this sleep circuit, and it's my way of testing the circuit without actually knowing what I'm doing in any kind of knowledgeable way. In other words, I get to play dumb. And so I've got diodes down there, and I got the secondary loop and I got this weird purple cord as my primary around a cast iron floor flange 9 inches across, and that purple wire is not multi-stranded like the 4-gauge wire here serving as the secondary, but the primary instead is copper-clad aluminum solid core, which isn't exactly what I'm supposed to use. I'm supposed to use multi-stranded, but be that as it may, this is the best I can do for feeling my way out. So consequently, instead of switching the ends here to keep everything straight, I have to switch the middle portion. I have to switch it in the middle because the diodes are here keeping things the way they are because of the capacitors. And yeah, the capacitors are keeping things the way they are, and along, yeah, not the diodes. So I have to take off, the primary has to come off and switch sides to go to the other primary over here, and then the secondary has to do the same thing. And yet still, like before, like the secondaries, the top connects with the top. See? It goes over the top. And this comes out the bottom. And it goes underneath. So again, the same thing applies. Now, if I can back up here. Here's the capacitor loop. And here's the short. And they're on two different lines, on opposite lines. And the short goes to the top load, the neon bulb and the little antenna. And in between the short and the capacitor loop, which is also CCW, by the way, just like these inner secondaries are counterclockwise, it goes to a load, and the load is inside the chassis, and the chassis is common ground coming from the capacitor loop, which would have gone to earth ground, the 56 rods of earth comprising earth ground. So it's not exactly, you know, this, obviously, and that was the whole point, was to come up with something different that maybe made some sense. And this makes a mild allusion to Clarence's reference to Tesla's Pierce Arrow car of 1931, in which he might have had an aluminum plate on the backside of the car, serving as a collector of sorts, instead of, or to replace, to substitute, or serve as the analogous function, as the 56 grounding rods. But there's no analogy, direct analogy, between the 4 grounding rods in the middle and this neon bulb. So consequently, I don't have it. It's not there. It's not here, I mean. Instead, I just have the top load, which I've placed over here because I believe Bro Mikey drew this up, and he had this over here. He didn't have the top load there, but there was another image, apparently, well, it was posted by Bro Mikey, I think. Actually, it might have been posted by Clarence. I'm not sure who posted it. But it had a, I believe it was a red overdraw here and a blue overdraw here, which went down to here and corresponded to an outtake from one of Donald Smith's videos in which he has red and blue cords, and if I'm assuming that the top was red, then the top cord went to the top load, to the neon bulb, the red cord. And so from that video I discerned that's where the top load goes. That's what's missing in the prior schematic that was posted at Energetic Forum. So on that basis I've continued to persist in the presumption that a top load is needed, which doesn't surprise me because in a lot of these over unity devices you have to have a preload that's always in the circuit whenever you turn it on before you even add in any of the actual loads that you're going to run, because without the preload the whole thing fries itself, or it doesn't work, or usually it fries itself. The load is there to protect the circuit from frying itself. The way that Clarence described it, it just won't work at all without the top load. And the top load in this case is a spark gap, which you're not going to get in a normal load. You're not going to get sparking action. So this spark gap here, going through rarefied air, serves a very particular purpose, which I don't fully understand, or even partially. I wouldn't even dream of partially understanding it, but the most I can guess is Tesla quote, that rarefied gases serves as a filter for high frequency passage of electrical energy of some kind or another. And so it's a kind of filter, I suppose, to get rid of high frequency discharges happening in here, but it can also be creating high frequency discharges in here, which could infect the system, and so consequently it's a way to cause some energy to be drained out of the system just through wasteful loss, right here, through an air ground, if you want to call it that. And this kind of waste is voluntary, conscientious by design, in a very refined manner, being high frequencies, which sets things up here to respond in a certain fashion, which, at least I don't really understand, but I think that's the thing. We create a causation here of a certain type to create a reaction in here. And I think that's what the purpose of the top load in this format is for. This chassis fully surrounds the load, and it doesn't really qualify it completely, because usually it's a capacitor situation in which this is counterbalanced by another piece, usually inside, a supporting piece that's insulated from everything and supports the load positioned inside the chassis. Now, usually the two pieces are floating plates. That's not the case here, because the chassis is connected to the earth captor loop, over the captor loop up here. This is the captor ground. So anything is possible. Maybe the antenna goes in here to serve as the other plate to this common ground. If that's true, then, or even if it's not true, there's one other thing that's very important, and that is that possibly, may not be important, but it might be, that the interior of this has to be covered with a dielectric, possibly the exterior as well, especially the exterior if this is exterior to this. But if this is placed on the inside, then this probably has to be covered completely with a dielectric and all the circuitry leading up to it in order to prevent arcing, and the interior of this has to be covered with a dielectric as well. One of the stipulations of air grounding was that all of the circuitry, all of the wires leading to the exterior of the device, or any air that would carry a charge from the outside to the inside of the device, all those surfaces and wires and contacts and junctions have to be covered with a dielectric. They have to be insulated. All the screw points where wires come together, everything, bridges, because you could have an ionic tunneling occur between one part of the circuit and another through the air and go into the chassis or into the circuitry and short it out and create a short where you don't want it to occur. That's an important point I'd never considered before, and since we have an antenna here, that might be an important point. Now, Donald Smith never pointed it out in the video that I saw his neon bulb being used, but that's not to say it's not an intrinsic feature, because nobody's been able to replicate Donald Smith, or if they have, they're not too outspoken about it. Clarence claims he did, and he's not very outspoken about it. So, obviously there are some extra little factors that are not so maybe apparent to the rest of us, that are just as vital as all the other factors in the circuitry of any of these things. And as they say, the devil is in the details, and that might be one of them. But I link to that post, it's on overunity.com, on my blog spot that's devoted to my putting my attention on this idea of Barbosa and Leal. And that would be Barbosa Leal earthcaptor.blogspot.com. These two capacitors on either side may be necessary to put them into phase lock, and the best or easiest way to do that is to interleave them. So I have them signed here, positive, negative, positive, negative. I have them signed here, but with a floating plate inserted in the middle, so that the signs alternate positive, negative, positive, negative, positive. And so basically this plate here is one side of a capacitor, and this plate here is the other side. The dark bars are the dielectric in between. The lines are the plates. So this plate here matches up to the opposite side of this plate here, and this plate matches up to this one, so everything's displaced one spot over. But then we have to separate and put a floating plate in the middle, not connected to anything. And that's so that the polarity is set up correctly, because, as I said before, the purpose of a capacitor is to set up polarization of charge to make it very distinct. And the more the capacitor charges up, the more distinct is the polarization, but still, predominantly, all that is being set up by the use of a capacitor is polarization of charge. But since I have two on either side and I want them to get into phase with each other, then I have to put them into phase lock somehow, and the best way might be to do an arrangement, putting them together like this. So I needed to say that to add to this video.